All right, guys, so we've been talking about this diagram for, I don't know, a couple of days now.
2 weeks ago.
Yeah, but I think we already I had 3 videos already, so we've been talking about this diagram, different parts of it. The one thing I'm not gonna do is, I gave it to you guys without all the wires. I'm not gonna draw it, because that's gonna take half an hour for me to draw every line on there, and that's not gonna be beneficial to you. But what I do wanna talk about today is a little bit about certain circuits and how we look at those circuits on these machines. Okay, so in the refrigerator, we have all kinds of sections. We have an ice maker section, we have a freezer section, refrigerator section. We have different things that's going on inside of this refrigerator. And a lot of times, certain components need other components to work. In other words, something else tells it to work or controls it or whatever. And sometimes they're not located right next to each other. Sometimes something somewhere else in the diagram is controlling something on the other side of the diagram. So we did talk a little bit about the compressor and everything. I wanted to start off with the ice maker itself. I showed you guys before in the Frigidaire ice maker, and I'll just look it up real quick. It was something called a flex tray ice maker, right? So let's see here. Frigidaire. So the flex tray ice maker, if we look at the diagram while that's searching right now, if you look at the diagram, where is the ice maker? Where is the actual ice maker in the wiring diagram?
J2J1
J2, J1.
J2J1.
on the AC side.
So J2, that J2?
No,
No,
on the
This
bottom.
J2?
Yes.
J2
J2 pin 1?
and J1 pin 4.
But
J1 pin 4.
But wait, J2 pin 1, J2 pin 1 is going to a door switch. That's not the ice maker. That's the ice maker, right?
Yes.
Okay, so
D5.
let's take a look at something here. If this is the ice maker, what does it say right there?
5, 4.
No, what does it say inside the ice maker?
See easy ice maker diagram.
Oh, so there's a diagram for the ice maker. There's 2 of them, one there, and there's another laminated one probably behind you guys. And we have one in the classroom too. But let's take a look at this here. So it says see the ice maker diagram, right? Where's the ice maker diagram here? This is the whole diagram. But before, I cut off this part here, which is just the LED lights and the board and some stuff down here. Where's the ice maker? It's not there, right? Well, remember this diagram has 2 pages. So if we go to the second page, I don't know why it was drawn like that. This is our ice maker diagram. Right? That's not the ice maker we have inside this refrigerator. This is a different ice maker. I'm going to show you. And then I want to explain to you something. So this is the ice maker that's inside that refrigerator now. It's called a flex tray ice maker. Okay. Where's that image? Lowe's is blocked, so that flex tray one I can't get. Okay, but here it is here. So, I don't know why every single one of these friggin' things are blocked. Alright, well I'll just zoom in on them. So the ice maker diagram that they're telling you to look at is this ice maker. But it's not in that fridge, so why are they telling you to look at that diagram? This is not in that fridge. This has got a plastic gear and all this other stuff in it. This ice maker was used by Whirlpool back in maybe the 60s. I know in the 70s for sure, 1970s. This ice maker's been around forever. It's called a Crescent cube ice maker, which, you know, if you cut the moon, let's say in half, the moon would be curved here and flat there, which is what they call a crescent cube. And that ice maker I showed you before made either 6 or 8 cubes at a time. So if they're showing this ice maker, but the ice maker that's up in the refrigerator section is not that ice maker, why are you showing this ice maker?
Are you guys looking for the bottom part of the fridge?
Yes, it's like some of these models, Frigidaire said that these little flex tray ice makers don't make a lot of ice. I remember when, I think it was LG, Samsung or LG, came out first into the market. And they had a little flex tray kind of ice maker. But customers complained that it didn't produce enough ice. That it only produced a little small bin full of ice. And there was a lot of people complaining about it. And LG had to come out and say, well, listen, this refrigerator was designed in Korea, and the ice maker was designed for that fridge, but Koreans don't use ice that much. So ice to them is not as important as Americans use ice. Where every time we drink water or put a soda, we have to have ice in there, you know? And they decided, well, the ice maker, we're not going to redesign the entire fridge for this little flex tray ice maker. So what we're going to do is the flex tray is up in the freezer in its own compartment. We're going to pre-wire the refrigerator and design it that if the customer wants, they can install a Crescent cube ice maker in the freezer section that runs independently of that ice maker. So it'll be in a freezer just like the old Whirlpool ones. Now when they made this ice maker, you guys have on your drives the actual whole breakdown of this ice maker from start to finish how it cycles. I'm not going to go over this one right now. But for a while, they came out with what they call a modular ice maker. And what this was is inside of the ice maker, inside the head unit of the ice maker, and let me see if I can find it, at least maybe an image of it. Let's see. Okay, so if you look at this one here, let me see if I can find the other one. Let me go to images. Okay, so if you look at this one here, you can see the little gear on the outside of that housing, okay? This was the redesigned Crescent cube ice maker from the original one. And let me see if I can find you with the, let me take the word refrigerator out of here. I don't know, I said Whirlpool, Crescent, Ice Maker, Frigidaire, but okay, this is one that I wanted you to see, but I wanted you to see, this is the other one sort of inside. I was trying to find a picture, but on the older models, if you were to take, there's a cover, this white cover here off. I keep touching the screen and it's not what I wanted to do. I'm sorry, hold on a second. So on the older ones, if you took this cover off, you'd see this is actually inside. You'd see a gold plate. You'd see this is a metal plate, like a gold colored, brass colored metal plate. And on the other side there you had a plastic gear, similar to the gear I showed you on that other ice maker. And they put 3 individual micro switches in there, one for water, one to control the cycle of the unit, and I forgot the other one. But then they went to this. This has no physical switches like this. It just has a motor. The switches are underneath this plastic. It's just two metal pieces that the plastic is opening and closing. And they called this a module. It was nice because if this ice maker failed, to go inside and change one of those little micro switches, nobody ever did it. Everybody just changed the ice maker. And they said, well, let's try to make it easier to service. So they designed this modular ice maker. You have this module on your drive.
The Whirlpool.
And this modular ice maker, well, they started selling for other brands besides Whirlpool. And this one here had a plug right there that plugged into where the wiring harness was. And it would burn up and go bad. And they had other problems with it as failure. So you'll find manufacturers will have one or the other in there. But going back to the diagram we were talking about, is that this here is not the ice maker that's inside that fridge. It's not the flex tray ice maker. So where is the flex tray ice maker? Before you guys bust your heads looking
It's not
for
on there, it's a easy flex tray or whatever, so it's probably its own separate diagram.
No,
No?
no. The actual brain of the ice maker is built into the main board. Okay, so the main board here is controlling the ice maker in the refrigerator section, the flex tray ice maker. We have the twist motor, which is the actual motor that twists the ice, twists the plastic tray, and then the tray like twists and the ice falls out. We have a bail arm switch. Does anybody know what a bail arm switch is?
The alarm switch is a switch that's connected next to the flex tray. It basically tells the machine when it's like.
Yeah, now the bail arm is part of the ice maker, and the switch is inside the ice maker, but there's an arm, so when the motor takes this tray horizontal and goes to flex it, there's a piece of plastic here that catches part of the tray, but the motor's still twisting it, so that's how the tray actually twists. It holds one end, but the motor's twisting the other end. And then when it pauses and stops, that's when it reverses and goes back up and fills with water. But as it's going to drop ice, there's an arm in all ice makers. On this one, it goes down. On some ice makers, it's that metal arm that lifts up. And what that is all the arms get out of the way, let the ice fall down into the bin. If the bin is high enough and full, the arm would hit it and not sit all the way down, and that would tell the ice maker stop. Okay? But this one, the ice maker itself, is the board. You only have a motor, a bail arm switch, and the actual twist tray sensor. So if you went to someone's house and this ice maker wasn't working, what do you replace? Do you replace the board or do you replace the ice maker?
Ice maker.
It would depend on what's wrong with it.
Huh?
Ice maker.
You'd replace the board.
You need a change.
Usually you replace the ice maker, but here's the thing, how do we troubleshoot it? We got diagnostics and we can force the motor, we can force it to drop ice, we can force it to do different things. But when we go into any ice maker and someone says it's not making ice, what do we look for? What do we look, without even taking a meter, running diagnostics and everything, I'm gonna go to someone's house and they're gonna say, Richard, my ice maker's not making ice. So I have to do a visual inspection before I start testing. What am I looking for?
I'd look for a
The,
frost.
Before anything else, making sure that the refrigerator is working.
Okay, well then the customer normally would call me and tell me the refrigerator's not cooling, not tell me it's not making ice, right?
no
I
cool.
check for frost
No
buildup,
cool.
or check and see if
Okay.
there's any components that could be jammed, right?
Frost buildup where though?
Where the flex tray may be, or frost buildup around the dispenser.
Like Samsung had that issue where they're covered to separate the ice maker from the refrigerator. They have to seal it because that compartment's got to be cold enough to make ice, but right next to it's making milk, or not making milk, but keeping milk cold.
Oh, I was like,
Cool,
what?
yeah.
Okay, but the thing is that when they first designed it, the box that the ice maker was in didn't seal too well, and warm air from the fridge was getting in, and it was freezing up the whole ice maker compartment. So Samsung came out with a repair kit that you use silicone and you had to seal and you had to do all these other things to seal it up and prepare it. But I'm not really looking for frost at first. Let's just say ice maker. Okay, the first thing I want to know, if an ice maker is not making ice, I want to make sure, is there ice in the tray? Why?
Because it's not gonna make ice if the ice tray is full.
Not the bucket. I'm not talking the bucket. I'm talking about the tray, that actually the water fills up the tray and that makes the ice.
It'll let you know if you have water coming in as well, or if the machine is telling the ice maker to give water.
Okay, so if I walked up to this refrigerator and I saw that there was ice in the plastic tray,
Yeah.
but the bin is empty,
Could be.
what am I focusing in now?
And the twist.
Okay,
Could
but
be the flex, could be the motor, could be the bail arm switch.
The twist motor.
okay, well the bail arm switch could be bad,
Yeah.
and then it would think it's full, right?
Mhm.
But I think one of the key things would be this tray sensor. On the bottom of this flex tray, and I mentioned it in one of the other videos prior to it. No, I'm sorry, this is the wrong one. Okay, on the bottom of this flex tray, if I can, I know I messed up a couple of my,
I remember you mentioned something about the tray sensor in regards to the ice maker. Just can you remember exactly what you said?
yes. On the bottom of this tray, and I'm trying to see if I can find a picture of it upside down. Give me 1 second here.
Couldn't we just go pull it up?
Huh?
Couldn't we just pull it up?
It's right here.
Okay.
On the bottom of this tray right there is the tray sensor. Okay, that is what is telling the ice maker, hey, it's ready to drop. That's all it is a thermistor. All it is sensing temperature. But it's going to what? What is that sensor connected to?
The water valve?
No?
No?
Look at the diagram.
The board?
What is this sensor connected to?
Yeah, board.
The main board. The sensor's going into pin 5 and 6 on J7.
J7 pins, 5, 6.
Okay, so again, remember I told you on this model, that ice maker inside has no brain. There's no computer board or nothing. So if you guys want to work on the ice maker and look inside, you see it's just one switch for the bail arm and a motor. But everything is running back to the board. The main board is taking the place of an ice maker with its own brain. Okay, so if I go to an ice maker and I see the trays filled with ice, that sensor, I've seen a lot of times the sensor break and it's hanging by the wires. If it's hanging by the wires, it's never going to touch the tray, it's never going to drop the ice.
Yeah.
Okay?
So it has to be direct contact with the tray.
Yes, and if you look in the picture, you'll see it's actually attached to the bottom of that tray. I could zoom in here for you so you guys can see it.
Eso no quiere decir que está mal
It's right there in the middle.
el sensor.
Yeah, that's a housing
Sí, está hanging.
that the sensor's attached to this wire and that's up inside. So that sensor is sensing the temperature of the tray, telling it to drop the ice.
The ice. No.
Okay? So inside this box here, there's really nothing inside of it. Not like any other ice maker that has its own brain. So what I'm getting at is not so much how to troubleshoot the ice maker as here you have 3 components. All of them, you notice that's got one plug here because that's the ice maker plug, are all connected and running that ice maker, but it's coming off the main board. You could all mount this sensor, right? Check the resistance value of that sensor. And if it's bad, then we change the ice maker. If it's good, what do we change? The board. As long as it's cooling properly. So now what if I go to a customer's unit and I don't see any ice or water in the tray?
Nothing.
No. But it's freezing. It's cooling fine. We don't have a problem with the cooling right now. But the tray is empty. Because it would fill with water. If it's not cooling, it would be just still filled with water. So what happened there? Think about process. The ice maker turns the water to ice. The sensor is on the bottom of the tray, says, hey, it's cold. the motor twists, drops the ice, the arm goes up, it comes back, the arm goes back down, and it stops, and then water comes in. But you go there and you don't see any water coming in. So now we have to do what? Diagnostics. We have to go into diagnostics and try to force that water valve to come with water in. Okay? What if no water comes in?
The valve is bad.
Huh?
The water valve is bad then.
The water valve's bad?
Yeah.
Could be. Water can be turned off at the house. I've seen the tube that brings water to the ice maker freeze solid. The delivery tube, they call it. Usually if that happens, the water valve is dripping. But which water valve would you replace? Look at your diagram. Now this is what I'm trying to focus on. It's like first I said, where's the ice maker? And you saw that there was two ice makers, one here, but this was the ice maker that we're gonna deal with. And now we identified this board as controlling that, but where are the water valves? They're not there. Well, the water valves aren't part of the ice maker, even though the ice maker uses them to fill with water, but they are not part of the ice maker circuit. They're someplace else in the diagram.
The freezer ice maker water valve?
Where the main inlet water valve.
Not the freezer ice maker water valve, that's the one on the bottom. That's the Crescent one.
Twist
That's
ice
in the
maker-
refrigerator.
Twist ice maker water valve.
Where does that say? Right here, twist ice maker water valve, huh?
Yes.
Okay, so now I'm going to clear this diagram. How many water valves need to energize to either get water on the door, okay, like you're calling for water on the door, or for the ice maker? How many water valves does it take for water on the door or ice maker?
The ice maker.
Two?
Hmm?
Two?
Two for what?
The water on the door and the ice maker.
How many
Main
water
inlet.
valves do you see?
I see a total
We have four.
Four.
And
It's gonna take four.
We have four.
We have
of,
four.
I see a total of 5.
5? What's the?
I see 1, 2,
Two,
3,
three, there's
4.
four.
Where's the fifth one?
Well,
No,
there's a
that one.
dispenser, twist ice maker, the condenser.
Condenser fan. You look at the rectangular box, you're not reading the words, are you?
I'm not.
Okay.
Okay, that's fine.
Okay.
But now,
But
but now to understand this, we need to understand a whole nother part of the refrigerator. Now, the point of my lecture today is not to say, oh, well, if you want to charge the compressor, you go here, check here, here, here.
No.
No. What I'm trying to show is like, okay, the refrigerator ice maker is not working. What's the problem? Okay, there's no water in it. Okay, now we're going to the water. We have to understand how the water circuit works. Now, I do have it, I think, in my Maytag diagram. So hold on 1 second. It's going to take me another second to get to Maytag here. Books and modules, refrigerators, refrigerators. I think it was under Maytag. It might be on this one, Ice Maker Fundamentals. So in this book here, guys, this is the Crescent Cube Ice Maker, not the modular one. But this explains how, I told you about the gear, that was the gear. This shows you the whole circuit from start to finish what it does. But I want to show you something else. I'm going to see if it's in this picture here. So it's not here, so I guess I have to draw it myself. It's okay. Oh, I thought I clicked on this. So, in the refrigerator, you have a freezer on the bottom, refrigerator on the top, and the ice maker's in this corner. Okay? the water comes in. How many valves does the water go to when it first comes into a refrigerator?
One.
Which one?
Main inlet water valve.
Okay, so we're gonna go main. I'll just put a little arrow here. Main valve. All right, where does it go from there? Where does the water flow throughout the refrigerator? If it comes in that valve, what does it do then? You see, we talk sealed system, we talk electrical thermostats, timers, and all these other stuff. But just to fix the ice maker, you have to know how the water flows through. You have to know everything about the appliance in order to solve a problem. Okay? So, what actually happens is it comes into that single water valve, and then it comes up here. Ooh, what the heck happened there? It just all of a sudden changed size. So then they come here and goes up to here. What's up there?
Filter.
It comes up to the water filter. So it goes here, and then you have the water filter. Oops. Water filter, okay? So, where does it go from the filter?
Well, go to the freezer.
You
go ice maker.
Twist ice
Oh.
maker and dispenser
We
ice
got
maker.
It goes what?
Dispenser ice maker
What?
and the twist ice maker. The same?
Nope,
No?
nope. It goes all the way back down to the bottom of the fridge, right next to that one. And we have two more water valves. Water on the door, and I would just put WD,
Oh, yeah.
and then flex tray ice maker. I'm not even gonna go over the Crescent one, okay? So it comes back down to this water valve, and then if I'm like want water on the door, this one sends water to the filter. Filter comes back down here. Water on the door goes where? Where does that piece go?
That's the
Ice maker.
dispenser one.
Dispenser.
No, this is water on the door. This goes to the dispenser? No.
Ice
No,
maker.
it's on top of
Go ice
No,
maker?
no, we're gonna go look at this refrigerator so you guys can see it, but I wanna go over it first. Because again, you know, your understanding of all this stuff is important. So even as simple as the water flowing through the machine, because I have guys call me and they said, I got no water here. Well, you have to backtrack. Where do you have water? Just like you're doing an electrical troubleshooting problem. If my motor's not working on a machine, I wanna know if I got power to the motor. If I got power to the motor will work, that's my problem. But I don't have power. I have to find out what in that circuit is stopping power getting there. But I have guys tell me, hey, I put my cup in the door and no water's coming out. Well, it could be this water valve, but then if you see this water valve goes to the filter, and this filter goes to another water valve. Why valves here and there? Before I even go the rest of the circuit. Why do I have a valve here and here?
Because the valve, that valve over there,
Which one? The
No.
F or the WDIF?
WD has to be cold when you go to the,
Nope, don't have to be cold.
Maybe freeze.
That filter's on the bottom by the compressor. It's not even inside the fridge. The only thing that's inside the fridge is that filter. It goes in the filter and right back out the filter. Okay? So what happens is manufacturers years ago didn't put a water filter in the refrigerator. You had to buy a water filter, pull the fridge out, the copper line in the back, you cut it, and you connected the line to the water filter behind the fridge. And then what happens? Someone says, oh yeah, I need a water filter. They put a water filter behind the fridge. And you go out there 15 years later and pull the fridge out, and it's the same filter that was installed when they installed it. Because, get it, most customers aren't going to pull the fridge out,
Oh,
turn off the water, install a new filter, clean up behind the fridge because it's all dirty and dusty and nasty, and then put it back.
put it back and go.
Yeah, they
Bye-bye.
don't ever get changed. So the manufacturer said, well, if we install it there where the customer could just push or unscrew it and put a new one in, we can get it so that we can have fresh filters in our ice maker. But not only that, now
No,
we can sell filters.
no
yeah,
open.
but so this-
And then what happened,
Yeah, you got it.
yeah, but look at this. GE, for example. My boys at GE, they're like, you know, we designed it so the filter's inside so we could sell filters, but then people are going over there and buying these cheap filters from filter.com. Cheapfilter.com. I think that's what it's called. Cheapfilter.com. G said, okay, go ahead. We're going to put a chip on our filters.
Damn.
And if a customer doesn't have one of our filters with the chip in it,
You're not guaranteed.
work.
Won't
You
the
you?
lose
ice maker water won't work.
Oh,
Really?
That's fun.
So you go to someone's house and someone changed the water filter, you got no water coming out, and here you are trying to do all this troubleshooting, and you didn't know that the ice maker has to be a GE
Compatible.
compatible.
Yep.
So now what the manufacturers of cheap filter have to come is have to figure out how to put the chip in it so that they can trick it to think it's a GE filter, right? Okay, but anyways, that is a problem that a customer could create, and they're going to call you out and say, hey, my ice maker water's not working. Well, is your filter good? Maybe the filter's blocked up. No, I just changed the filter and it stopped working.
Oh.
You put the cheaper one.
Did you go to cheapfilter.com and buy it? No, you guys think I'm laughing. There is a thing that says cheap filter.
No, it's the filter is expensive in my house.
Yeah, but there's a website. They sell them like
It's
in
more
packs of
cheaper,
3
yeah.
and stuff like that. It's called cheapwaterfilter.com.
Yeah.
So anyways, they put the filter here. The reason why they have the additional valve is so when the ice maker or you're not calling for water, you could just pull that valve out and pull the filter out, because this valve will stop the water pressure from going through the filter. Because remember, if it was behind the fridge, you had to turn the water off to change it. And then when you turn it back on, that valve leaks, or it leaks behind the fridge. In this case here, when you pull it out, that does that. But see, GE also said, well, we didn't put the chip in there because we don't want customers to buy the cheap filters. We put the chip in there because if the customer accidentally takes the filter out and the ice maker doesn't know it's out, the ice maker can call for water, and this thing's going to start shooting water down in my refrigerator. That's why we put the chip in there. True. That's what they're going to tell you. We didn't put the chip in there because we didn't want them to buy anybody else's. Wink, wink. Okay? We put it in there so that it doesn't shoot water. Now, some manufacturers, like Maytag or whatever, when you take the filter and you unscrew it and you drop it down, the plastic piece it was attached to turns and it bypasses the filter assembly. Some manufacturers have a little bypass cover where you unscrew the filter and you put this piece in and it bypasses the filter and allows everything to work without a filter in it in case someone doesn't want the filter. What if someone has a water softener or some sort of filtration system in the house and doesn't need to keep putting filters in? Why do I have to have 2 filters? I filter my whole house water. Why do I need to filter that water again? I'm not spending 40, 50 bucks on a filter that lasts 3 months or 6 months.
6 months.
So that depends on how much water you drink. You got
Oh,
a family
yeah,
of 10 kids and they're all in and out.
Yeah.
Okay, so that's why
I
this.
paid $70.
Now, we do need to talk about this. This is important because there's something happening on the diagram electrically that if you don't know about it, you'll never know how to fix this problem. Okay? So there's more to this than just the water. So when it comes in here and goes to the water on the door, we still say, where does it go? Well, here's your dispenser here where you put your cup. You know, your glass is right here. And the little hose right there for the water. But guess what? It doesn't go right back to the dispenser. From the water valve, it goes back out the back of the refrigerator and goes out the back of the fridge and goes into the refrigerator section, either to a hose that's coiled up or an actual tank that has an in and an out. And that tank is in the refrigerator section. And it holds about 8 to 16 ounces of water. So if someone puts a cup there and gets water, they get chilled water. But what happens if 3 people used 8-ounce cups and the container only holds 16 ounces? The third person is going to get the water from the hose, but it hasn't sat in the refrigerator long enough. It's not refrigerated. It's like as if you took a container, filled it up on the sink, and then put it in the fridge to have cold water. Well, if you took it right back out, it's not cold. It's going to take time, right? And that's the same thing with these refrigerators. But man, we got another problem. So from here, how does it get to the door? How do we get to the dispenser? We got to run back out of the refrigerator. We came in the fridge. We got to go back out the refrigerator and go through the upper hinge here, and inside the door is a hose. Now, on a side-by-side refrigerator, your dispenser's here and all your valves are down here. Your compressor's down here, and any hoses running down here are going to get warm from the condenser and the compressor. So even though this is chilled water, the hose between here and the door, or the hose between the tank and the refrigerator and coming out here is running underneath here before it goes up there. So the hose itself has 2 or 3 ounces of hot water or warm water. So when a customer puts their cup, they get 2 or 3 ounces of warm water. Then the water from the hose finally makes it and mixes with that warm water. So the customer is going to complain and say, my water's not cold. And it could not be cold. And manufacturers say, listen, this is not a water fountain. This chills water. That's why we have an ice maker and an ice dispenser there, that you put the ice in and you put the water with the ice. Seriously, that's what the manufacturers tell me. Okay? So look at the water flow. Here, here the water valves, tank, and back. So this ice maker one will go out the refrigerator and run right up to the ice maker up here and come down through the top. Let's go take a look at the routing of the water lines on that unit for a minute, and then I'm going to go back and show you electrically what happens with these valves and something you need to know about, okay?
This is the main one.
See. The recording started, by the way.
Okay, yeah. So I'm going to take this water valve out here. There's your 4 water valves right there. 1, 2, 3, 4. Okay, so if we look here at the valves, we got one valve here. Let's see, where is the inlet? Oh, right here. So this is where the water's coming in. This is our inlet valve. And notice it comes out of this valve and it runs up here to this hose here, this yellowish looking hose, and goes into the back of the box. Now everybody come around to the other side. Oops, sorry.
You're good.
So that line that came out of the water valve, like I showed you in the drawing, goes immediately to the water filter, and Frigidaire just makes it so you push it in and it pops right out. Okay? On the side-by-side Frigidaires, I saw that a few of them had problems. Like there was a wall here from the freezer cools the fridge, that the cold air was hitting the water filter and freezing the water filter. You got to see if water comes out. Okay, you can hear it. That when you change the water filter, you have to run a few glasses of water to get the loose carbon that's in here out. But you also want to make sure it's not frozen. You could go to someone's house and the ice maker and water not working, and you could have a frozen water filter, or you can have an older water filter that's blocked up and not passing water through. So when I'm talking about backtracking, is that if I thought my problem was at my water filter, when I take it out, there's something in there that prevents water from shooting out of here if I called for water on the door. Okay? So I would have to get back behind here, remove this component, and I would see those 2 lines and they're different colors, and I would disconnect the line going in, and I would press to see if I got water shooting there. That lets me know valve number 1 is pushing water up here. Then the return water goes out. So if I take the inlet hose off and I see water shoot out, I connect it. And the one thing nice about these are called John Guest fittings. I'll show you on the other side how to use them. But anyway, so it goes in. So then I take the other hose off and see if water comes out. Then I know it's not my filter. So in other words, just like an electrical circuit, you're backtracking to see how it works or whatever. We're backtracking to see how much water is flowing through. Okay, let's go back to the back of the fridge again. Let's go back to the other side. So this goes into the water filter. This one comes back down. Now real quick, let's look. These are what we call John Guest fittings. And all you have to do is, if you look at this little collar right here, just push up on the little collar like that. And while you're pushing up on the collar, pull the hose right out. So I'm pushing up on that little collar right there. To connect it, all you do is push it and it's connected. I recommend you get 5/16, 3/8, and 1/4 inch John Guest fittings and keep them on your truck. Sometimes these hoses down by the compressor, they get very hot, dry, and brittle, and you might have to like cut a piece of hose out and reconnect it. Having these extra connectors on your truck can get you a completed call like that. Okay, so anyways, this white line is coming back down, and where does this white line go? This white line is going here to the back side of this valve. And just like my drawing, what does it do? It goes to the water on the door and the ice maker. Now, how do I know which one of these two is water on the door and which one of these two is the ice maker? Well, this one here is going to up top, right?
Yeah, going to
And so is this one. Ice maker is always these small little 1/4 inch lines. Okay, so if we followed this one up here, it changes to this line, but it's 1/4 inch here. This one here is going up, and we'd have to remove the hinge cover, and you'd see it go down, and it would go into the ice maker. You want to see something here? You're not going to see it here, but this one goes to the ice maker. What does this one go to?
The water dispenser.
The water dispenser on the door. So this one's coming up. It's inside. If you look how big this hinge is, can you see right in here?
Yeah.
I hold it up. You guys want to see? Can you get that on the camera? Can you see the hose right up underneath there? That's the water on the door. It goes down through the hinge and comes into your dispenser here. You guys see that? The hose underneath there? Okay, so that's water circulation. What am I missing? What didn't we talk about?
The tank.
The tank. So let's go back in the refrigerator section. And I don't see a tank.
Right side.
On the older Frigidaires, there was a filter on the side, and this housing was a little bit over, and the tank was there. Let's take all this out. There's no tank.
No,
That's a freezer. If the tube or hoses were there, they'd freeze. So the only thing I can tell you is that this is the only place you're going to get chilled cold water from on this particular unit. But the older ones, you're going to see here on Frigidaire. On other ones, you're going to see in the back wall. What's this hose here? We didn't talk about that hose.
Bottom freezer ice maker.
Yes, that one there is going down to the freezer, and that's for the second Crescent cube ice maker.
There's a second ice maker.
It has the ability to install an easy
Okay.
ice maker.
Okay.
So now let's go back and look at the electrical circuitry of this.
Pause video.
Yes. Okay, so let's go back to the schematic. I think it's that way. So let's take a look at this schematic. If I want water on the door, how many solenoids do I have to energize? Telling you, how many solenoids do I have to energize?
Two.
Two. Give me the name,
The
please.
main inlet and the water dispenser.
So we got the main inlet here, right? And we have the dispenser water valve. But watch what happens here. I want to energize my machine, right? So I'm going to send power in this tan. It's going to go through here and go to the main water valve, and from here it's neutral, it's going to go out. Okay? But I want this dispenser water valve, which is also coming off this tan here, and going like that. right? But we got a problem. Because if you look at this circuit here, it goes back this way and also goes to my twist ice maker. And if I want to go to the circuit on the bottom, it's going to my freezer ice maker, like all of them are going to get energized at the same time. So, looking at that diagram closely, how do they prevent water valves from being energized that they don't want to energize? Because we only want this one and this one on. How do we only turn on those two? So J5 is my water on the door. Okay? The key is this right here. What is that?
The displays, the diodes.
Diodes. What do diodes do?
They only let
They control-
electricity flow one way.
It only lets electricity flow one way. So if you look at the diagram here, when I come in that tin and I go through that diode to my inlet valve, it can't go back because the other two diodes won't let the current go back that way. So this tin's being energized, that's how the water's going on the door. Let's look at the ice maker, the twist ice maker circuit. So now if I want to do the twist ice maker, I go yellow here, and I go through this wire for my main valve, and I come back through this other yellow wire here for the twist ice maker, but the two diodes, the top and the bottom one, are preventing current from going back, so it doesn't energize. Why is that so important? I have seen these diodes short out and not open, like a switch goes bad and it says an open switch. When a diode shorts, it only allows electricity to go one way and not back the other way. But when a diode shorts, current can go either way. And then what would happen if, let's just say, that diode right there shorted out, the top one out of the three? What would happen?
Water would be going straight through the dispenser. It would be coming out, right?
Say it now again.
Water would be coming in straight through that, out of the dispenser water valve.
I'm not following. So, just the dispenser water valve? Just the dispenser water valve? So in other words, I energize this. Will I energize the twist ice maker valve? Yes. But I'll also energize the main inlet, but then it'll backfeed to here too. So you know what? A customer's going to call you out on these Frigidaires and tell you, hey man, I woke up this morning and I have water all over my floor. And what happened is the diode inside the wire harness shorted. And every time the ice maker went to drop ice and call for water, it filled up with water. But it also sent power to the water valve on the door, and it's throwing water on the floor. Or the vice versa could happen. What if the one for the ice maker shorts out? What if this one shorts out? So then I come in here, I feed my twist ice maker, right? I feed my main inlet, and I'm sorry, I didn't want to do that. I want to do the water in the door. Then I go through here to the dispenser on the door, and if this one's shorted, the ice maker one, not only will water come to the cup, but while I'm holding my cup there for water, the voltage comes back, and the ice maker's also filling up with water. So while you're there holding your cup, calling for water, the ice maker's shooting water, and you're flooding the ice maker compartment. If either one of those diodes fail. Now the diodes are on the bottom left-hand side and they're part of the wiring harness. You have to replace the whole lower harness of the refrigerator to fix that kind of problem.
Wow.
But if you didn't know those diodes there and what they did and that they're part of the harness, you wouldn't be able to fix the problem. There's no information there telling you what those diodes are and what they do. But that's what's happening. So this bottom one is when the freezer ice maker calls for water. But in this case, it comes off the ice maker itself. The ice maker has power. Actually, it has light blue, which, no, it's got black here. And it comes in here. So why do we have a door switch connected to it? Why do we have a door switch connected to the ice maker?
I have a bone to pick with you later. What?
You what?
I said I have a bone to pick with you later because that was the first one I said, and you said no, that's not where it comes in. It comes in through the bottom one on J14.
This is the bottom ice maker.
No, that's not what I mean. But I'll talk about it after. I don't know.
Where is that switch? Just by looking at it.
That's a switch in the freezer door. So, that's why. Yes,
Why?
because it is exactly where the freezer door would be. On the bottom, the freezer door switch would be.
So that's on the left-hand wall below the ice maker.
Correct.
And if someone opens the door and the ice maker is running,
Yeah.
well, the bucket is on the door or in the basket. So if you open up the door, the basket
would
comes
be-
out,
Yeah.
not water. The ice maker would drop ice and it'd fall in the bottom of the freezer because the ice bucket's not there. Even if the ice maker's halfway through dropping and the fingers are just about to drop, if someone opens the door, they stop. The ice maker just sits there and waits. Then when you close the door, it finishes the cycle. But it's a safety device so it doesn't drop ice into the freezer when the door's open.
Yeah.
But again, when it wants water, it's going to send power through this yellow-blue wire here, the ice maker, and it's going to come back here, and this is going to go to the main inlet and also go here, but these two diodes above are preventing these valves from coming up. Any questions, guys? So we have a water circuit problem. We have an electrical circuit problem. These are things that we need to go. So going back to when we said we got ice in the tray and it's not dropping, what would you do on that ice maker going all the way back to where we started? You went there, you want to see if there's ice in the tray. If there's ice in the tray, but it didn't drop, could the motor of the ice maker be bad? The twist motor be bad?
Yeah.
So it doesn't drop?
It could be bad.
So that's where we go into diagnostics. And we force the ice maker to drop that ice and go through a cycle and see if it turns back and calls for water again. Now, if it drops the ice and goes back to the cycle and fills with water, what would you replace?
Can you repeat this?
If you go to someone's machine, the flex tray, and you see ice in the tray, you go into diagnostics and you say, drop the ice.
Would it be the tray sensor?
Most likely the tray sensor is bad. Very good. The tray sensor here is possibly the problem because it's not sensing the temperature and telling the board, hey, drop the ice. But again, troubleshooting these things out, you have to understand how they operate. And have to know there's no control board in there. These wires here are plugged to the main board and the main board's telling it what to do.
And if the diagnostic is working, that means the board itself is working.
Yeah, if the diagnostic is telling the motor to drop the ice, there's nothing wrong with the circuitry to the motor to drop the ice in the first place. So the only thing is wrong is it's not telling the board to drop the ice. When you go to diagnostics, you tell the board to drop the ice, but it's not doing it on its own. Now, this works off of what?
Temperature.
Temperature. Oh, now we've added more problems to it. Because now, if we look at this ice maker, the ice maker has its own evaporator. Has a fan back there. It has its own way of making ice. Where's my pen? Oh, here. Okay, so where is that evaporator fan for the freezer?
On the low voltage side?
For the ice maker, okay? So where is it? This is the ice maker fan, right?
Yes.
So in this compartment, when you look all the way in the back, after you take the bucket out, there's a fan back there. And not only is there a fan back there, but there's an evaporator behind it. Okay? So that evaporator is controlled by here. Ice maker, evaporator, and defrost bimetal. If I have a defrosting problem in the ice maker compartment, would that cause the compartment to get warmer and then not drop ice?
Yeah.
Yeah, because if it doesn't defrost, it'll make the compartment warmer or lose air circulation. So here you go for an ice maker problem. You have ice in the tray, you've dropped the ice, but what you need to know is the temperature of that compartment. Is it cold enough to tell it to drop the ice? So you see how a simple ice maker problem, we could have water flow, we could have an electrical problem, or it may not even be the ice maker, it may be a freon problem, it may be a defrost problem in that compartment that's not allowing it to get cold enough and do its job. But the refrigerator could still operate. If it's defrosting, it's just a little tiny evaporator up in the freezer compartment, and if it don't defrost, then we have cold problem, we don't make ice. So you see, when I make you guys work on these machines, and I tell you, don't rush the machine. When you find parts, you need to know every part and what every part's function is. The more you know, the easier it is to troubleshoot. But look, we started off with water, then we went to electrical, now we're talking about defrosting. You're zoomed in on the wrong area. Okay, so here we can have a defrosting problem. Is there a door switch that stops the ice maker in the freezer?
Door switch that stops the ice maker in the freezer.
I'm not the freezer, in the refrigerator compartment, I'm sorry, I
I'm sorry,
misspoke.
what was the question? Say that one more time.
You know how we said that there's a door switch here, this one right here would affect that ice maker there, but that's the ice maker in the freezer, and that's a little switch on the left-hand wall in the freezer. But I said, is there a door switch that tells this ice maker, hey, the door's open, don't drop the ice?
No.
No. Because it drops into a bucket that has nothing to do whether the door's open or not. But there is a door switch that affects what?
Water.
Water and ice
dispenser,
dispense. The actual dispensing of it. They take it from the bucket and go through the door. And if we look, those are where? It's right here, I circled it.
Yeah, I was gonna.
Now these here, oh wait a minute.
Oh, there isn't.
It's the same switch here and there, but this is the switch because look, there's my auger motor right there, and it has to go through those two switches. But these two switches and these two switches are the same. The bottom one here, left half, the bottom one here, or the top one, left half. This is right, this is right. Only difference, we have a low voltage circuit, high voltage circuit. 120. So a low voltage circuit like tells the board, hey, the door's open, let the customer know. And that's like when you walk away and you hear beep, 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 instead you shut the door. Okay? But that also has an effect on what the machine's doing. Now this one here is actually stopping the ice maker motor. How does it stop the water valve? Because if I'm looking here, the water valves are way up here and none of them go through that switch or this switch, does it? Does the water valves go through any one of those switches? Yes, no, maybe?
No.
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 So I'm thinking more likely one of these low voltage switches are telling the board not to turn on the water. Because the water valve's not going through the actual main door switch. So those switches are probably also telling the board, hey, don't let them call for water because the door's open.
Yeah.
Does that make sense?
Yeah.
Yeah. Your Frigidaire, in the office, when the door is open, I want to take a water.
You
no,
can't.
No.
No, all refrigerators do that.
All right.
All refrigerators, if the door's open, you can't dispense.
Okay.
That's a safety mechanism,
Yeah.
Yeah,
alright?
yeah.
Okay, guys, I'm gonna stop for today. It's been an hour. I usually only go about an hour.
Beautiful friend.
We have more stuff to cover, but I wanna break it down in little pieces because the more we talk about this diagram, the more you understand the whole refrigerator. But there's so much to it. Once you get through this one, the next fridge is gonna be easy because you're gonna find similarities in its circuitry and how it works to the other refrigerators.
This might be a stupid question, but the auger motor is the ice maker motor, right?
No,
No,
the
push
ice
the
maker
ice.
motor is
Yeah.
the twist motor.
Twist.
That's the one that's causing the ice maker to drop the ice. The auger motor is connected to the bucket. So when the ice maker drops the ice into the bucket, the auger motor is the one that spins that little piece of metal in the bucket as
Nice.
that's
Push
called
the
an
door.
auger. A drill bit is an auger. You ever seen like when they drill in the ground to put a fence post
Yeah,
or
yeah,
something? That drill bit is called an auger. And it's the same thing in your ice bucket.
Yeah.
Got it. Thank
I
you.
tell you the
Yeah.
Okay?
It was beautiful today, man.
Always good lectures.
No,
Beautiful,
it was-
beautiful.